Pre-calculus 4.7 day 2. So we have a warm-up here for you to practice the inverse functions, make sure your angles are in the zone. So I would suggest just pausing and working through these, and then when you get done with them, checking. Let's see how you did. So when you see inverse sine, you need to have an angle that is between negative pi halves and pi halves. That's the zone. So as I work this, I'm going to first say, what is the cosine of 2 pi thirds? And when I'm thinking of 2 pi thirds, I'm thinking on the unit circle. This reference angle right there is pi thirds, and the ordered pair would be -1/2 and up root 3 over 2. That's where that 2 pi thirds ends on the unit circle. And the cosine of that is the x coordinate. So that's -1/2. Now I want the inverse sine of -1/2. And that has to be the angle between negative pi halves and pi halves. And so it has to be in that zone. And we have to rotate clockwise, thinking of this angle as a negative pi 6, this angle's negative pi 4ths, this angle's negative pi 3rds, and then this is your negative pi halves. Those would be the exact values on the unit circle. And I'm focusing in quadrant 4 because the other quadrant would be at quadrant 1, negative pi halves to pi halves. Well, sine's positive in quadrant 1, so it must be one of these quadrant 4 angles. And so it's which one of these on the unit circle has a y-coordinate of -1/2. And it would be the negative pi 6. If I was thinking about the triangle that corresponds with it, you would be going long and then down short. And so this is root 3 over 2 down -1/2. This reference angle is your pi 6 or 30 degrees. And so the y-coordinate of that angle is the -1/2. And so this inverse sine, the angle is negative pi 6. It cannot be a positive 11 pi 6 because 11 pi 6 would not be between negative pi halves and pi halves. It's not in the zone. You have to rotate clockwise and use that negative pi 6 as your angle. In part B, inverse cosine, when I see inverse cosine, you're resulting, the output is an angle, and it is an angle that has to be in the zone for cosine. And that zone for cosine is not the same as sine. It's 0 to pi. And so the first thing I'm going to do is figure out what is the sine of a negative pi. So I'm thinking, okay, if I rotate this direction, it's one of those quadrantal angles on the unit circle. That's a rotation of a negative pi. And so this right here on the unit circle is -1, 0. And the y-coordinate is the sine of negative pi. So sine of negative pi is 0. Now, for inverse cosine of 0, I want the angle between 0 and pi whose cosine is 0. And cosine is the x-coordinate. And for 0, it isn't one of the pi 6, pi 4ths, pi thirds, or 2 pi thirds, 3 pi 4ths, or 5 pi 6. It's not one of those. To get a 0, it's one of the quadrantal or axial angles. And on the unit circle, this point's 1, 0 when the angle is 0. When the angle is pi halves, this is 0, 1. And when the angle is pi, then this would be -1, 0. And so on which one of those is the cosine of the angle going to be 0? Well, the cosine is the x-coordinate, so it's going to have to be this one, and that angle corresponds with pi halves. And pi halves is between 0 and pi, so my answer is pi halves. How'd you do? All right, so 4.7 day 2. We're going to continue with inverse functions and add a few other things to them. And so in number 1, they want you to evaluate the tangent of this. And when you see inverse cosine of 4/5, you need to think of that as an angle. I'll just think of it as theta. And if I have the inverse cosine of 4/5 is theta, that means the cosine of theta is 4/5. And so this is an angle, not just any angle, it has to be an angle between 0 and pi because of the restrictions on inverse cosine. And so this in here is really the ratio of sides of the triangle, and it's positive. So I'm saying all of this, since the ratio is positive and the limitation on the angle is 0 to pi, it must be in quadrant 1. And so cosine is adjacent over hypotenuse, so I'm thinking I can draw a triangle where the adjacent side is 4 and the hypotenuse is 5. So here's my theta. And the adjacent side would be this, and the hypotenuse would be 5. And it has to be quadrant 1 because the ratio is positive, and since it's inverse cosine, it has to be a quadrant 1 or 2 angle, and cosine's positive in quadrant 1. So now I want the tangent of that angle. So I don't actually find the angle. This is not a no calculator problem. It's a no calculator problem. So I want to see the triangle drawn. And so then we need to do 4 squared plus b squared equals 5 squared, or just know that that's going to be a 3, 4, 5 triangle. It's a nice Pythagorean triple. And so the tangent of that angle is going to be opposite over adjacent. And so the tangent, the angle is this. That expression means an angle. And your answer is 3/4. All right. In number 2, again, this is no calculator. And when you see arc sine, that's the same as inverse sine, that expression is an angle. And that angle, if it's inverse sine, has to be between negative pi halves and pi halves, because that's the restriction on inverse sine. And so if the arc sine of negative 0.3 is my theta, that means the sine of theta must be the ratio. And so that I can think of that as sine of theta is negative 3/10, and sine is opposite over hypotenuse. But since theta has to be between negative pi halves and pi halves, but it has a negative ratio, then I'm going to be rotating this direction and drawing a triangle in quadrant 4. So here's my theta, and we're rotating clockwise. And so if I set that up, and there's my theta, the opposite side is 3 and the hypotenuse is 10. And I can think of that side as being negative in terms of the y-coordinate would be negative in quadrant 4. And then I need to find the tangent. So what I'm thinking of, this is theta, so the tangent of arc sine of negative 0.3, I can substitute theta in for that arc sine. I'm letting theta be that angle. And that tangent is going to be opposite over adjacent. And I know theta is quadrant 4. And so tangent is negative in quadrant 4 because it works with y over x. And so I need to find this side of the triangle. So a squared plus a negative 3 squared equals 10 squared. And so you get a squared plus 9 equals 100. A would be plus or minus the square root of 91. But since A is corresponding with that adjacent sign, A is going to have to be the positive because that's what would work with the quadrant, or the triangle being in quadrant 4. So this is going to be a positive square root of 91. So this point, we're not on the unit circle because the radius is 10, but this point would be square root of 91 comma negative 3 on that triangle. And so tangent is y over x, so it's a negative 3 over square root of 91, or that means the tangent of this angle, rationalized, is a negative 3 root 91 all over 91. All right, and so, again, this expression, arc sine of a negative 0.3 represents the angle, and the tangent of that angle is that negative 3 root 91 all over 91. All right, and then we have write an algebraic expression that's equivalent to the sine of the arc cosine of 3x. So we have that arc cosine of 3x, and we are going to then say if the arc cosine, if I let that just be my angle, that means the cosine of the angle is coming out to 3x. And I'm going to think of that as over 1. And cosine is adjacent over hypotenuse. So I am going to draw a triangle, and I'm just going to make it here in quadrant 1, where this is theta. And cosine is adjacent, and the hypotenuse is 1. And so the sine of this angle is going to be opposite over hypotenuse. So I need to find this side, and I'm going to need to do that algebraically. And so we have 3x squared plus b squared equals 1 squared, or 9x squared plus b squared equals 1. So b squared is 1 minus 9x squared. And so b would be plus or minus the square root of 1 minus 9x squared. And inverse cosine is an angle between 0 and pi. So the triangle could have been situated here, or it could have been situated over here. But irregardless, the y-coordinate is going to be positive. Sine in quadrant 1 or 2 is always positive. So b will be positive. So it's going to be that positive square root of 1 minus 9x squared. So the sine of that angle is going to be the square root of 1 minus 9x squared over 1, which is just the square root of 1 minus 9x squared. That is not 1 minus 3x, by the way. You can't take their individual square roots and subtract. This is as simple as it gets. And so theta was the arc cosine of 3x, and the sine of that angle is this. So there you have it.